Welcome to homework.
We are given strings. We are asked to determine whether it is generated by the grammar for infix expressions from a previous exercise 40. And if they are generated, to find the steps used to generate this string. So in part A, we're given the string x plus y plus z. Now, using our solution from exercise 40, we had that the operators, it was very similar to infix notation from exercise 39, except the operators were placed between operands like factors and terms, and the parentheses were required in expressions that were used as factors. So we had factor : equals, and then we had bracket, identifier, line, parentheses, bracket, expression. So in part A, we see that this string that we're given, x plus y plus z, is not generated by the grammar, because the addition operator can only be applied to two terms. In a way, this is sort of the whole point of infix notation. And we have that terms that are expressions must be surrounded by parentheses. So we would need that x plus y should be surrounded by parentheses, or y plus z should be surrounded by parentheses. So in other words, this string is not generated by infix grammar. In part B, we are given the string a/b plus c/d. We see that this string is generated by the grammar. Notice that the substrings a/b and c/d are both terms, so they can be combined to form the expression a/b plus c/d. And we will derive them using the steps expression. In the next step, we have expression can be replaced by term, followed by add operator, followed by term. We have that term can be replaced by factor mul operator, factor on both sides. So we get factor mul operator and factor, followed by the add operator is replaced by plus, and then we have another factor mul operator factor, which I'll write distance from the margin. This is still part of the same step. And now we see that our first factor can be replaced by an identifier. In fact, all the factors can be replaced by identifiers. The mul operators can both be replaced by slashes. And in our last step, we see that the first identifier can be replaced by an A, the second identifier by a B, third identifier by a C, and the fourth by a D. So we get the string that we desire, and therefore it follows that the string is generated by infix grammar. In part C, we're given the string m star n parentheses n plus p. So the question is this generated by the grammar? This string is generated by the grammar. To see why, notice that parentheses n plus p is a factor because it's an expression n plus p contained in parentheses. And then all you have to do is recognize that that is a factor, m is also a factor, and then multiplication is a mole operator. So it's all one term. And so we can derive it using the following sequence of steps. We start out with the expression. In the next step, we replace expression with term. In the next step, we'll replace term with factor, mole operator, and factor. In the next step, we'll replace the first factor by identifier, replace mole operator by the asterisk, and we'll replace factor by parentheses bracket expression. Now, in the next step, we can replace the identifier on the left with m. We can replace expression with term add operator, term, and we see that we can replace term with factor, we can replace add operator with plus, and we can replace the other term with another factor. We can replace both factors with identifier, so we get m asterisk parentheses identifier plus identifier. And in this final step, we can replace first identifier by an n and the second identifier by a p to get m asterisk parentheses n plus p. And so we've shown that the string is generated by the infix grammar. In part D, we are given the string plus m minus n plus p minus q. And this string, we can see almost immediately, is not generated by the infix grammar. For one reason, we notice that it's impossible for an expression to start with an operator in this grammar. So we cannot start with a plus. We would have to have a term preceding it or a factor preceding it. and therefore it follows that this is not generated by this grammar. Finally, in part E, we are given the string parentheses m plus n asterisk parentheses p minus q. And in fact, this is similar to part C, except for now, instead of just having m before the asterisk, we now have the expression parentheses m plus n. So this is also going to be generated, and to see why, we'll derive it. So we have expression. In the next step, we get term. In the next step, from term, we get factor, mole operator, factor. In the next step, we see that our first factor is going to become parentheses expression. Our mole operator becomes the asterisk. And our second factor also becomes parentheses expression. Our first expression is going to become term, add operator, term, and the second expression also becomes term, add operator, followed by term. See that the first term becomes a factor. The first add operator becomes plus. Second term also becomes a factor. And the third term becomes factor. The second add operator is replaced by minus, and the final term is replaced by factor. All the factors are replaced by identifiers. This is a bit sloppy. I think you get the point. And finally, we have that the first identifier is replaced by an M, the second by an N, the third by a P, and the fourth by a Q. So we get parentheses M plus N, asterisk, parentheses, P minus Q. And this is exactly the string we wanted to generate, and so it shows that this string is generated by the infix notation.